Friends, we were discussing about a set of hydrocarbons, that is alkenes and also alkanes. Alkanes are the hydrocarbons which are having connected carbons through a single bond. Alkenes are the set of organic hydrocarbons which are having double bonds along with single bonds. And we know that alkanes are most stable and most unreactive species. Only reaction the alkanes can undergo is substitution reaction, which follows free radical mechanism. Whereas alkenes are having the pi electrons in excess. That's why it can act as a seat of nucleophilic center. Hence, it can undergo electrophilic addition reaction. If our compounds contains two double bonds, then they can be called as dienes, or they are also named as diolefins or alkadienes. Today's subject of discussion is about these dienes. Dienes are the molecules with two alkene units. It contains two carbon-carbon double bonds. We know that alkenes have the general formula CnH2n. Carbon and hydrogen is in the ratio of 1:2. Whereas dienes are having the general formula CnH2n minus 2. Dienes are classified into three types depending upon the position of the double bonds in the molecule. The first step type of dienes are isolated dienes. It has two double bonds, and these two double bonds are separated by two or more single bonds. The simplest example for isolated diene is 1,4 pentadiene. As it is indicated here, penta means there are 5 carbons and the position of diene is 1 and 4 position. CH2 double bond CH, CH2, CH double bond CH. There are two double bonds, one between the first and second carbon and another between the third and fourth carbon. And these two double bonds are separated by two single bonds. It is separated by two or more single bonds. These are isolated dienes. The two alkene groups are isolated. Another set of dienes are cumulated dienes. These are also named as allenes. This cumulated dienes, the two double bonds are connected to the same carbon. The simplest example for cumulated diene is propadiene. Here you see there is a central carbon and two carbons attached to it, and the central carbon is having attached to the carbon over here with a double bond, and oppositely another carbon with another double bond. The last set of or type of diene is conjugated diene. This conjugated dienes also has double bonds, two double bonds, and these two double bonds are separated by one single bond. In other words, there is and alternatively a single bond and a double bond. The simplest example for conjugated dienes are 1,3-butadienes. Buta means 4 carbons, 1, 2, 3, 4. At the double bond is at 1 position and at 3 position. And these two double bonds are separated by a single bond. This comes under the category of conjugated dienes. The conjugated dienes are of prime importance because the double bonds in this conjugate dienes are conjugated with each other. Conjugate dienes, the simplest butadiene I have taken as an example, they can be prepared by three different methods. In the first method, I'll take an alkene 1, 2, 3, 4, 1 butene and treat with N-bromosuccinamide in the presence of UV light and carbon tetrachloride as solvent. The bromination of the alpha carbon occurs to give rise to 3-bromo 1-butene. This 3-bromo 1-butene can undergo beta elimination in the presence of ethanolic potassium hydroxide. This K plus and OH minus abstract an hydrogen from here, creating a carbon ion, and this carbon ion excess electrons it shares with the adjacent carbon, and the adjacent carbon has to maintain its tetravalency, and bromide ion is an easy leaving group. That's why it kicks off bromide ion, loses HBr, and elimination of hydrogen and bromide occurs at alpha and beta position. That's why we call it as beta elimination, and it gives rise to 1,3-butadiene. The same 1,3-butadiene can be obtained from 1, 4-butanediol. Here, butanediol can get dehydrated in the presence of concentrated sulfuric acid and heating. It gives rise to 1,3-butadiene. Butane 1,4-diol undergoes dehydration following the mechanism which we have explained in the alkenes. It gives rise to corresponding 1,3-butadiene. The same 1,3-butadiene can be obtained from 1, 4-dibromobutane, and it can undergo beta elimination in the presence of ethanolic potassium hydroxide, and I'll get butadiene. These are the major methods of preparation of conjugated dienes. Conjugated dienes are highly stable. That's why conjugated dienes are having a special place in the organic chemistry. Why they are stable? What are the factors that affects the stability of these conjugated dienes will be the subject of discussion for the coming class. Till then, have a nice day. Thank you.